with 7-4. So in 7-4, you're going to be simplifying radicals. That's not the heart of the lesson, but you need to know how to do it to get the best answer. So I'm going to show you a list of all the perfect squares because you're going to use those a lot. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, and 100. Okay, if you want to just write those down at the top of your homework just so you can see them and it's kind of in your brain, you're welcome to do that. Rarely do we go above 100, so this should be plenty of perfect squares for you. But what you're going to be doing today is you're going to have to give answers in simplest radical form. Do you remember simplest radical form? Basically what it is if I'm taking the square root of 75 and I want to break that into simplest radical form, here's the way I do it. I go like this. I do a perfect square and the one that is not a perfect square. So I always put the perfect one out in front and the one that's not at the back. You'll see why in just a minute. So here's the idea. The square root of 75. Up here are all these perfect squares. Which perfect square is 75 divisible by? 25. So you put a 25 here. 25 times what? 3. 3 is not a perfect square. Okay, now look at those numbers. Can you simplify the square root of 25 or the square root of 3?
25.
You can simplify the square root of 25. What is it? 5. It's 5. So we write that as 5 times the square root of 3. So this and this are equal, but this bottom one is the good answer, okay? This is not simplified. So when you get to this point in the homework, you need to break it down into simplest radical form, we call it, okay? Let's try another. The square root of 18. Is there a perfect square that 18 is divisible by? 9, okay? So 9 times what gets you 18? 2. So if we simplify that, that is going to be the square root of 9 is 3. Get rid of the radical. A lot of people leave the radical there and they just keep putting more radicals and more radicals. Don't do that. The square root of 9 is exactly the same thing as the number 3, right? So we get 3 rad 2 in simplest radical form. Okay? You try this one. The square root of 200. Don't tell us, just do it. And then you can tell me in a minute. What's your final answer? 10 rad 2. 100 is the perfect square. 2 is the non-perfect square. The square root of 100 is equal to 10. The square root of 2 we can't simplify, so you get 10 rad 2. Any questions on that? Coming back? Remember that? Okay. Then what we're going to do in this lesson is going to use a little bit of that. So 7-4 is all about similarity in right triangles, and this is a little different than similarity in every other type of triangle, okay? When you have a right triangle, first of all, let's just talk about the pieces of a right triangle because this is how the terminology I'm going to use. I want to make sure you know what is what. So you have 3 sides. Can anyone tell me what the longest side in a right triangle is called?
The hypotenuse.
The hypotenuse. Okay. And then you have 2 what's? What do we call the other 2? HL? Legs, okay? But you're going to have 2 legs, one of which is the shorter leg, and one of which is the longer leg. Okay, so that's the terms that I'm going to use when referring to the pieces of a right triangle. So make sure you have a shorter leg, a longer leg, and a hypotenuse. Now, sometimes I will do SL for shorter leg, LL for longer leg, and just H for hypotenuse. So if you see those, that's what I'm referring to. All right, so theorem 7.3. Here's what it says. It says the altitude, do you remember what an altitude is? It's like a height, right? It goes perpendicular to the opposite side and it goes through the vertex. So the altitude to the hypotenuse of a right triangle divides that triangle into two more triangles, this is beautiful, that are similar to the original triangle and to each other. Isn't that fantastic? So you end up with 3 triangles and all 3 of them are proportional to each other. Ooh, does anyone else get chills from that? Because that's so fun for me. I know, I'm crazy. So here's my recommendation, okay? You have 3 triangles. You don't have to do it this way, but if you're struggling at all in this lesson as we go through it, this is going to be your best way, okay? When you take a look at this and you're trying to find missing pieces, I think it's easiest if you just redraw the 3 triangles so that they all have the same orientation. The shorter legs all sit here. The longer legs all sit here. And the hypotenuses all sit here. Okay, now you don't have to draw them the same orientation as me, but this is how I will always draw them if I draw them. Yes?
How do you get the third triangle?
Ah, yes. Okay, so your first triangle, your smallest triangle, would be this one, right? ADC. Your medium-sized triangle would be this one, CDB. Your biggest triangle is the whole thing. That one. Does that make sense? Yeah. So they're all overlapping and they're all proportional to each other, but you have to just be really careful about what falls where. So here's what I want you to see. If we're looking at these 3 triangles right now, in the smallest triangle, what is your right angle vertex? What's the letter? Did that make sense how I asked it? In the smallest triangle. Yeah, your vertex would be D. So technically there's a right angle right here that they didn't draw in, but it makes a straight line. It's a right angle, okay? So this letter right here would be D. What would be right here? That's A. Your shorter leg is DA. So this is A, and this one is C then, okay? Your middle-sized triangle is nice because it's set exactly how we see it right now. Your vertex that has the right angle in it is D. The other side down here is B. And then the top one is C. Okay, and now the biggest triangle is usually the one that gives people the most trouble because it's usually not facing the same direction. And it's just kind of funky to think of it the way it's set up. So where's the right angle in the big triangle? C. Okay. What's this one up top going to be? That's A. Ooh. And then the other one? B. Okay. So you have these 3 triangles. They're proportional. You can say shorter leg over shorter leg equals longer leg over longer leg, or hypotenuse over hypotenuse equals longer leg over longer leg. And that makes it really nice when you have them drawn like this. Some of you don't need to draw them. Some of you are just going to see it. Like, you'll look at the picture and you'll go, oh yeah, I don't need to draw those. I can see where everything falls. That's fine. You don't have to draw it. A lot of you should draw it, okay? So if you're like, I'm not sure, draw it. Just take my word for that. Okay. I'm not even going to do the proof part of it right now. We're just going to skip that. We're going to set this up so that we can write a similarity statement for the 3 triangles in this picture. So if I have triangle, let's say this is E, this is G, this is K, and this is A. Okay, why don't you draw the 3 triangles and label them? And like I said, I always draw it the shorter leg vertical, the longer leg horizontal, and the hypotenuse on the diagonal. I'm going to do it that way right now, so you might want to just stick with that way, but that's up to you. So 3 triangles, go ahead and draw them. And then I want you to see if you can label the points correctly. Did you get them? Okay, so in this first one, what did you put for the right angle? G. Yep. And then the one above that should be E. And then that leaves this one as A. Okay. The middle size triangle, again, your right angle is G. What goes above the G? That's the A. And then over here is your K. And then in the big triangle, now this one's nice because the big triangle is sitting exactly how we have it drawn here. So this is A, this is E, and this is K. Okay, so that means you should be able to write a similarity statement for me for these 3 triangles. We can say triangle EGA is similar to what triangle? AGK, which is similar to triangle EAK. Okay, so that would be our similarity statement for those 3 triangles. And like I said, if you can see that without drawing them, great, go for it. We're gonna get into some numbers pretty quick, and that's where you might have a little more trouble laying it out, but we'll see how it goes. Any questions so far? Okay, now we're gonna apply some things here. The first is what's called a geometric mean. And remember, this is an average idea, right? The mean, the average, the geometric mean will be this number or this number if A over X equals X over B. So there's gonna be one side that's the same on both triangles that we're using, and it ends up being A over X equals X over B, okay? So for instance, when they give you a problem like this that says find the geometric mean of 5 and 12, those 2 numbers that they give you are your A and your B. We're gonna say this is A, this is B, and we're gonna set it up as a proportion with the unknown, with what is the geometric mean. So we're gonna say 5 over X equals what? X over 12, okay? So you see what we're doing there? We're just replacing the A and B in a proportion. X stays the same on both of them. So now what we can do is we can cross multiply. 5 times 12 is 60. X times X is X squared. How do you solve for X? The square root. Yeah, we're gonna square root both sides. Okay, well now here's the deal. X is equal to the square root of 60, but that's not the best answer. Here's where my little worksheet comes into play. Is there a perfect square that 60 is divisible by? And you always want the biggest perfect square, because there might be multiple ones. You want the biggest one. This one only has one. 4, yeah. 4 times 15 is 60, so X is what? 2 rad 15. Okay, so when they ask you what the geometric mean of 5 and 12 is, it's 2 rad 15. Okay, you're basically taking an average-ish in a geometric way of the 2 sides of a triangle. Okay. Okay, so here's what happens. There's a corollary to that first 7-3 theorem that we talked about. This one uses the smallest triangle and the medium-sized triangle to set up a geometric mean type situation, okay? Here's how it works. Oh, no. Oh, no, we're okay. Sorry, I thought I lost a piece. So looking at the two smallest triangles right now, here's what I want you to see. And I'm going to like shade and try to make this as straightforward as I can for you. So here's one triangle, right? That bluish color, and then the medium-sized triangle. I hate that I'm a perfectionist because I have to like color in every piece of it. That's annoying, but there we go. Good enough. So in this setup, can you tell me, actually I don't have it labeled. I'm just going to tell you. This is the shorter leg of that blue triangle, right? What is the shorter leg of the pink triangle? It's the altitude, right? It's this one. This is the shorter leg of the pink triangle, okay? But that same piece is also which part of the small triangle? Do you see it? It's the longer leg, right? So the shorter leg on one triangle is the longer leg on another triangle. That's your geometric mean. This is your longer leg of the short triangle. And where's your longer leg of the pink triangle? It's up top here, right? Okay, so if you were to redraw the triangles, you would see how these match up. Shorter leg has to correspond to shorter leg. So it goes shorter leg. Let me color code. The shorter leg over the shorter leg of the pink triangle will equal the longer leg of the blue triangle over the longer leg of the pink triangle. Okay? Yeah.
How is that one longer? Like
Which one, pink or blue?
It doesn't matter. Just like the longer leg.
Just looking like the length of this versus the length of this, right? This one is shorter than that one.
But what about the one diagonal?
What one is this one?
Yeah.
That's the hypotenuse.
Oh, okay.
Right? The one across from the right angle is always the hypotenuse.
Okay.
Yes. Oh, okay. I see what you're asking now. Yeah. So notice the shorter leg here and the longer leg here, that's the geometric mean. Those two are going to be the same number. Okay? That's how this is going to come into play a little bit for you. So let's label this. Let's say this is A, B, C, and D. If I'm going to set this up with the small and medium triangle, I'm going to go shorter leg of the small triangle over what's the shorter leg of the medium triangle? The altitude, BD, right? So AD over BD, I switched colors on you, I'm sorry, equals, now I'm going to go shorter leg of the medium triangle, longer leg of the small triangle, BD over the longer leg of the medium triangle. Okay, that proportion will always be true in right triangles like this. Okay, there's a second corollary. I promise we're going to apply these in just a second. This one uses the biggest triangle and then either the small or the medium triangle with it. So this one's going to say hypotenuse over hypotenuse equals longer leg over longer leg. I'm just going to write it like this. Hypotenuse over hypotenuse equals longer leg over longer leg. Or this one's going to say hypotenuse over hypotenuse equals shorter leg over shorter leg. Okay, and I'm not even going to label that one because it's all the same pieces. Just know that now your hypotenuse is here for the biggest triangle. It's here for the medium-sized triangle, and it's here for the small triangle, right? So you have 3 hypotenuses. Just pay attention to where they're falling. Okay, all that to say, we're going to do this. You have 2 triangles here. I want to know the value of x, and I want to know the value of y. Now, in this setup, this is where we draw. It makes so much more sense if you draw the 3 triangles, how we want them set up. So I'm going to start with this triangle. This is my smallest triangle, right? And I'm going to draw it right here, the same orientation we've been drawing it. So my right angle right here. What's my shorter leg in that first triangle, that bluish triangle? How long is it?
4.
It's 4. Okay, that's this side right here. What's my longer leg on that triangle? Y. And what's my hypotenuse on that triangle? X. Okay, so there's the 3 pieces of the smallest triangle. Do you see it? Okay, now the medium triangle. In the medium triangle, you might want to just draw your right angle in. This is a right angle right here. What is the shorter leg?
Y.
It's the Y. This one is shorter than the 5, right? So Y is the shorter leg. The longer leg is what? What's the hypotenuse? We don't know. They didn't give it to us, okay? Now the big one, and honestly, you don't need to try to draw these to scale necessarily, but I'm just going to show you so that you see it. Here's your right angle in the big triangle, okay? What's your shorter leg in the big triangle? X. What's your longer leg in the big triangle? We don't know it, right? That's this one, so we're just going to leave that blank. What's your hypotenuse in the biggest triangle? 9. Good job, you guys. So many people tell me 5 or 4. Add these together, right? This is the hypotenuse across from the right angle. Now, this should be a fairly easy problem to solve for x and to solve for y. So once you get it drawn, it's not so bad. Here's what we do. If I'm going to solve for x, where do you see x's?
Short leg and the big one, and hypotenuse and small one.
Right, the first triangle and the last triangle. So that's probably where we're going to work. Not always, but most likely to have enough information, okay? So we can say 4 corresponds to x, right? So 4 over x equals what? X over 9. Hypotenuse over hypotenuse. Cross multiply that, and we get x squared equals 36. What is x? 6. Take the square root. X is 6. Okay. Questions on that? Okay. Moving on. Now we want to solve for y. Which 2 triangles do you think we'll use to solve for y?
Small.
First and second, the small and the medium. Set up a proportion for me. What to what equals what to what?
4 over y.
Mhm.
4 over 5.
4 over y, shorter leg over shorter leg, equals longer leg over longer leg. Cross multiply it. We get y squared equals 20. Take the square root. What do we got to do? Simplest radical form, right? The square root of 20 breaks down into what perfect square and what non-perfect square?
4 and 5.
4 and 5. So we get y is 2, square root of 4 is 2, rad 5. See how drawing them is a little simpler? If you're just looking at it like this, it's hard to go, okay, shorter leg over shorter leg equals longer leg over longer leg. What are we looking at? If you draw it, you see it a little better, okay? Okay, letter B here. I'm going to have you try on your own for a couple minutes. So if you need to draw it, draw it. If you're like, nope, I can see that I have a shorter leg with a shorter leg and a hypotenuse with a hypotenuse. Great, do it that way. But I'm going to give you a couple minutes here. Try it out. Feel free to talk to your neighbor as you do it. and then we'll do it together and we'll be done. You might not be done, that's okay, but let's just see how you're doing. So on this small triangle, you should have your shorter leg is 12. What is this one? Longer leg or hypotenuse? That's the hypotenuse, so that's going to go here, okay? So 12 and Y. On the middle size triangle, you have a longer leg of 16 and a hypotenuse of X. And then on the big triangle, you actually have everything. You have a shorter leg of Y, right? This is your shorter leg. A longer leg of X, that's down here. And then the hypotenuse, you got to add those together, 28. Okay, is that what you got for your pictures? Hopefully. Okay, so now from here, now you can start to set up what matches up with what. Let's solve for X. How did you set up a proportion for X? 16 over X, so that's longer leg over longer leg, right? Medium and big triangle equals what?
X over 28.
X over 28, good. So cross multiply that, you get X squared equals 448. Okay, so then 448, now we gotta break that, take the square root into a perfect square and a non-perfect square. Did anyone get it? 64, yeah. So this is 64 times 7. Do you know how to check that? How to figure it out? Go 448.
In the first place, I can never really understand that part.
How did I get 448?
No, it's 64 and 7.
Yeah, that's what I'm going to tell you right now. So you'll take your calculator and you'll type in 448, and then you look at your list of perfect squares. 448 divided by, I always start high and work my way down because you want the biggest one. It's the least amount of work. So 448 divided by 100, you should be able to tell that's not going to work, right? 448 divided by 81. 448 divided by 64, and that one does work. You get a whole number, you get 7, okay? So when you get the whole number, that's what we're looking for. So this becomes 8 rad 7, and that'll be your answer, okay? What did you do for Y?
12 over Y equals Y over 28.
Yep, shorter leg over shorter leg equals hypotenuse over hypotenuse. Okay, and then cross multiply. So Y squared equals 336. So try this real quick. If you want to find this, do 336 divided by, again, 100 isn't going to go into 336, right? 336 divided by 81. 336 divided by 64. 336 divided by 49. Keep working your way down until you find the one that works, which is which one? 16, yeah. So 16 times 21 is 336, which means Y is 4 rad 21. Questions on that?